In this video, we are going to see how to draw an hyperbola. The question is construct a hyperbola with the distance between the focus and the directrix as 50 mm and the eccentricity as 3 by 2. Also draw normal and tangent of the curve at a point 30 mm from the axis. First you write the given data. The distance between the focus and the directrix, that is CF, is equal to 50 mm, and the eccentricity value is given in the problem 3 by 2, and also they are asking to draw a tangent and normal at a distance 30 mm from the axis. Solution: first you draw the directrix line and the axis line, and the directrix and the axis both are meet at the point is C, and now we are going to fix the mark the focus point. The focus point distance is 50 mm from the directrix C. Okay, so from the point C I am going to fix the focus point. So this point name is F, and here the eccentricity value is 3 by 2. The eccentricity value is equal to 1.5. The eccentricity value is greater than 1, so the given curve is hyperbola. Okay, and need to add the numerator and denominator. The numerator value is 3 and denominator is 2, so we get 5. So we need to divide the distance between focus and directrix into 5 equal parts. 50 divided by 5 is equal to 10 mm. Okay, so 10 mm we are going to divide the distance between C and F. Okay, we need to divide into 5 equal parts. So 1, 2, 3, 4 and 5. So now we need to mark the vertex point. So here on the numerator the value is 3. So from the focus point, third division, first 1, 2, 3. So this is the point for vertex. So we mark V. Okay, and now take the compass. Before that you draw one vertical line from the point V, and now take your compass and place V is the center, and measure the distance of F, V and F, and trace one small curve, and that curve meet on the vertical line. So that point, this point name is S. So here the VF distance is equal to VS, and now you connect the point C and S, and then trace one straight line. And now I am going to divide the line from the vertex into some equal value. So I am going to divide by 10 mm. Okay, so from the point V I am going to divide the line. So this is the first 10 mm, then 20, then again 10 mm, and again 10 mm, 10, 10, 10. Okay, so like I divide the line into some equal divisions. So now I give the name for the line, number on the line, number on the division points. So this is 1, 2 and 3, 4, 5, 6, 7. Okay, so here the curve comes on infinity. Okay, it continues infinity value. So up to this 7 division or 8 division is enough. And now from all the points, point number 1, I am going to draw one vertical line. And now from point 2 I draw one vertical line. So from all points we need to draw a line. So after that we give the numbers on the top portion. So here this is 1 and 1 dash. Here this is 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, and 7 dash. Now you measure the distance between 1 and 1 dash and place focus is the center and make an arc on the first line 1 and make an arc on the first line above and below the axis line, above and below the axis line. And now measure the distance between 2 and 2 dash and place focus is the center and make an arc on the line 2 and 2 dash above and below the axis line. And let's measure the distance on 3 and 3 dash and make focus is the center. So for the 3 and 3 dash line, the line is on the focus point only. So measure the distance and make the arc 3 and 3 dash above and below the axis line. And let's measure the distance 4 and 4 dash and place the compass on the focus point and make an arc on the 4 and 4 dash line above and below the axis line. And let's measure the distance 5 and 5 dash and place the compass on the focus point and make an arc above and below the axis line. So like you continue the arc on the various lines. So now I am going to give the name on the various points. So this point is P1 and here P1 dash and this one is P2 and this one is P2 dash and this one is P3 and here P3 dash and this one is P4 and here P4 dash and here P5, here P5 dash and this point is P6 and here P6 dash and this one is P7 and here P7 dash. So now we are going to trace a smooth curve through all the points. So we start the curve from the vertex point. So from the vertex point so first you draw lightly and then you darken the curve. So this is the hyperbola curve. Okay, so in the question they are also asked to draw the tangent and normal line at a distance 30 mm from the axis. So here this is the directrix line and this one is the axis line. So from the axis line we need to mark 30 mm on the curve. Okay, and then you mark the point P. Through the point we draw the tangent and normal. So I place a scale on the axis line and I'm going to mark the 30 mm distance from the axis. So at this point on the curve the distance from the axis is 30 mm. Okay, so I mark the point and I give the name on the point. This point name is P. So from the point P we trace one line. That line is connected to the point F, P and F. Okay, so I am connecting the point P and F. And now Now I place the protractor over the line P and F, and F is the center point, and I take 90-degree angle, and now I am going to connect the point F and the 90-degree angle. The angle is 90 degree from the point F. I trace one straight line. The line meets the directrix line. Okay, so from that portion, from that point, okay, from that point I'm going to connect the point P. So this line is tangent line. So here T and T dash. The tangent line never cross the curve, hyperbola curve. Okay, so we trace the tangent line, and now we are going to trace the normal line. So now I am going to place the protractor over the line, on the tangent line, and the point P is the center, and I take 90-degree angle, and here I am going to trace one line through the point P. So that line is normal line N and N dash. Okay, so finally we need to darken the hyperbola curve, the tangent and normal line, also the directrix and axis line. Okay, after that we need to mention the dimension. So here the distance between focus and the directrix I'm going to mark here. So that value is 50 mm. So I draw the dimension line and make the arrowhead, closed arrowhead. The center I write the dimension 50, and no need to write the unit near the dimension. And here also the distance from the focus and the point for the tangent and normal is 30 mm from the axis. So here I draw one extension line, and from here I write the dimension 30 mm. So this value is 30. So after that, in the bottom of the diagram on the right side corner, we need to write T dash is equal to tangent, N dash normal, all dimensions are in mm, scale 1:1. Here also in the curve we trace one leader line, and here we mention the curve is hyperbola. Okay, so this is the procedure for draw a hyperbola curve.